Hi friends, welcome back. Today we're talking about perpendicular bisectors in circles. Perpendicular bisectors in circles. Grab your notebook, you're going to want to write this theorem down. If a chord is a perpendicular bisector to another chord, then that first chord is the diameter of the circle. Also, the converse of that. If a diameter is perpendicular to a chord, then it bisects that chord. So we know that in this first one, if a chord is a perpendicular bisector, and I know this is a perpendicular bisector because I have a perpendicular angle, I'm shown that's a right angle right there. I know it's a bisector because it cut these two in half. So if I have both those things, then I know that this first chord here is also a diameter. Now, the converse of that is if I know that this guy is a diameter and I know that it's perpendicular to a chord, then it bisects that chord, knowing that it is the diameter. So again, we don't assume anything in math. We always double check it. So let's see how that works out for us. Let's take a look at our first one here. All right, so on these, we want to find x. Find x, the value of x. Sorry, that was not included in the instructions there. So, okay, now looking at this guy, it looks like our x is a radius here, right? So that is also the same for this radius right here. This radius and this radius. No matter where it is on the circle, if it's a radius, if it goes from the center outward, then they're equal. So this radius right here is 7.1 plus 4.5. And if I add those together, I end up with 11.6. So 7.1 plus 4.5 gives me 11.6, which means x equals 11.6. All right, let's try a harder one. So taking a look at this guy here, we need to find the value of x. Well, in this case, we know that since this is perpendicular, and we know that this goes through the center, the diameter, so we're using the converse of this theorem. This is also right here 20.7 because it is a perpendicular bisector. It goes through the diameter and it's perpendicular, therefore it's a perpendicular bisector. So I have this triangle here and it's a right triangle because we have that perpendicular angle. And when I have a right triangle and I don't know a side, I can use Pythagorean theorem. So I'm going to say x squared plus 20.7 squared. And remember, those can be in either order. The legs of it could be 20.7 squared plus x squared equals 22 squared, but that one has to be your c, right? So a squared plus b squared equals c squared, and our c is always our hypotenuse or opposite our right angle. Okay, so if I minus 20.7 squared minus 20.7 squared. So now I have x squared equals 22 squared minus 20.7 squared. I can't just subtract that and say, oh, that's like 1.3 or whatever. You have to actually enter it into your calculator like that. So if I do 22 and I square that minus 20.7 and I square that, I'm left with 55.51. So x squared equals 55.51. Square root both sides, and we can use square root, and then I'm going to use this handy answer key, answer, and I get 7.45. So x is approximately 7.45. So that's that little bit right there. Now, since this part is 7.45, just so you can see, then this part right here, how would we go about figuring that out? Well, we already have the length of the radius, which is from here to here, which is 22. So for this part right here, I would just take 22 minus 7.45, and I end up with 22 minus 7.45, we get 14.55 equals 14.55. So now you know how to find that little bit as well. All right, so let's try, actually for those guys, we will see, let's try one harder one. Okay, so let's take a peek at this guy. Sorry, it has to focus there for a minute. The black to white thing messes with it. All right, so looking at this guy, we know that it goes through the diameter here and it's perpendicular. So therefore, these guys are going to be congruent. This is congruent to this, which means that's also 8.6. Now, I'm going to call this y right here, that little bit, that's y. And then 18.6 is for the whole diameter. So that's 9.3 here and 9.3 here because I only need the radius right here. So what I have now is 8.6 squared, that's the leg, plus the other leg, that y squared, equals the hypotenuse squared. So now I have y squared equals, and if I minus 8.6 squared from both sides, so now I have 9.3 squared minus 8.6 squared. So I have 9.3 squared minus 8.6 squared. Just like that, we get 12.53. So y squared equals 12.53. Square root both sides, and we get y equals 3.54. Okay, so now we know this little bit is 3.54. However, I need this x here. Well, I know an entire radius is 9.3. So if I take 9.3 and I subtract 3.5, 9.3 minus 3.5, I end up with 5.8 equals 5.8. So x would equal 5.8, this little bit right in here. Hopefully that helps. If you have any questions, leave them below. Otherwise, we'll see you next time.